Hello students, let's begin lesson 4, differentiation. Differentiation is a process to find out the derivative function, which is defined like this. For original function f of x, the derivative function f prime of x is defined as the derivative value of f at x assigned to each x value. Now sometimes we use f prime of x, which is French notation by Lagrange, but sometimes we use dy over dx, which is German notation by Leibniz. They are the same, but most of the time we are going to use prime notation for simplicity. Now we have this limit here, so it is possible to find out the derivative values through the limit computation, but that's often a difficult thing to do. So most of the time we use derivative formulas, and these are the typical formulas that you have to remember. First, some preparatory formulas. The derivative of constant is always 0, so any constant just goes away. The derivative of sum is sum of the derivatives, alright? So that you can take the derivative term by term. And finally, coefficient. You can multiply by the coefficient either before or after, it doesn't matter. And then we have the main rules: the power rule, the exponential rule, and logarithmic rule. Here's the power rule. The power comes out as coefficient and subtract 1 from the power. How about the exponential rule? Exponentials stay the same. I mean the natural exponentials stay the same. And as for the logarithmic function, here we go. We get 1 over x, which is equivalent to x to the negative first power. You see, power forms are always most useful, so whenever you have 1 over x, or any fraction or any radical, it's going to be a good idea to change the power form first. You can do it power form conversion either before or after. In any case, please remember to change the power form. That's very, very useful. And then here are some more general cases where we have arbitrary bases, but let's not worry about these for the moment. Let's go ahead with some example problems, even though some of them may be reviews. Okay, let's have some preparation. H of x is e to the x power. Okay, that's good. And then x to the e power. Again, that's good because this is exponential and power. And then ex. That's okay too, but let me emphasize that this is a power rule, so x to the first power. And x over e, this looks like a fraction, but as a matter of fact, it's 1 over e times x, or x to the first power, to be a little bit more specific. Next, e over x. Now, that one requires some real work. If you change it into negative first power, then you can clearly see that you're using the power rule. And finally, a constant. Okay, so much for the preparation. And then let's take the derivative. Exponential stays the same, alright? And then the power function. Power comes out, and then x to the e minus 1 power. Next, power comes out, but that's just 1. And then we have 0 power, but nobody writes like this. 0 power is just 1, so we have just e. And then same here, 1 over e, because if you have x to the 0 power, then that's just 1, so you can throw that away. And then how about this? E was there, but power comes out as coefficient. Oops. And subtracting 1 from the power. Of course, nobody writes like this. We write it as minus of e times x to the negative second power. And then finally, subtracting 0 because this is constant. Again, nobody writes like this. We can stop here. Alright, how about this problem? Well, we can take the derivative of this, which is 0 plus 1. And then let's take the derivative of this. 0 minus 3 minus 60. Is this right? The answer is no. This is wrong. Why not? Because if you have product of two functions, that's not the derivative of, that's not the product of two derivatives. So the derivative of sum is sum of the derivatives, yes, but derivative of product is not the product of the derivatives. So this is wrong. Now, how do I make it right? Instead of using product, we can use the addition rule. Fold it out, and then we can apply the power rule one at a time and add them up. You see? No, not this one. The derivative of product is not the product of the derivative, but derivative of sum is sum of the derivatives. So if we expand by additions, then we can take the derivative term by term. If you have product, then you can't do that. And here's a solution. Fold out and break up everything, and then take the like terms together, and we get this simplification. And then now we are ready. Take the derivative. Power rule, power rule, power rule. And the last one too, that's gone because that's constant. All right. Now, how about this problem? For this, let me expand the font. Again, it is quite tempting to do it this way. What is the derivative of this? Well, let's take the derivative of numerator. So this is 6x squared, and then derivative 6x to the first power, and then derivative just 1, and then constant is gone. And this derivative is just 2. Is this right? The answer is no, not really. What happened here? The derivative of quotient is not the quotient of the derivative. It doesn't work this way. Just like the product case. The derivative of product is not the product of the derivative. Likewise, the derivative of quotient is not the quotient of the derivatives. So it doesn't work this way. How do you make it right? Well, there can be multiple ways, but one way to do it right is to expand out like this. Separate all the numerator. So the first, and then the next, 3x squared over 2x, and then plus x over 2x, minus 4 over 2x, excuse me. Oh, sorry about the cough. I'm recovering from COVID right now. Sorry about that. Anyway, we successfully separated the numerator, and then we can simplify each term. So 2 over 2, so number part is 1, we get just x squared. And then next we have 3/2 x to the first power. And then we get 1/2 after canceling x out. And finally, minus 2x to the negative 1 power, because x is now downstairs. So much for the preparation. And then let's take the derivative. You see, after doing all these kind of things, you may get exhausted and think this is the end of the problem. But no, remember, you didn't take the derivative. This is just manipulation. This is just a preparation. Changing everything into power form. Now, everything is now in the power form. Oh, excuse me, wrong key. we can take the derivative. What is the derivative of this? 2x. And what is the derivative of this? 3/2 x to the 0 power, but that's gone because that's 1. And plus 1/2 is constant, so that becomes 0. So you don't really need it. Now, negative of negative 2, so plus 2 x to the negative second power if you subtract 1 from the power. That is the derivative function. Make sense? Well, here's the answer key. This is the way I usually do. Separate the numerator and then simplify and then apply the power rule. But some students do it this way. Change this denominator into multiplication. Number part is just 1/2, so no change there. But this is coming from the denominator, so we have negative first power. And then FOIL it out, we get this form, which is the same as before. And then you can apply the power rule one at a time. Of course, we get the same thing. Some students prefer to do it this way. Me, I usually do it this way by separating the numerator. Let me show you both in the same window. In any case, the derivative of quotient is not the quotient of the derivative. Remember that. We need some further manipulation. And then we have some tangent lines to consider, but let's not worry about that. And so much for section 1.